Let's solve this question. For example, here is the light of description of description of molecules in a matter. So in order to see what's the difference between solid and gas, free to move around from one place to another, this is a gas, can vibrate about their fixed position, this is a solid, closely packed, relatively far apart, almost no force between the molecules, strong force are involved between the molecules. That's the this part. In the columns alongside the description next to use the molecules, a solid or a gas, that's what we just did. The water in the puddle of rainwater is evaporating. Describe what's happened to the molecules when the water evaporates. Type, what will happen to the molecules? So we said before that for in evaporation to occur, what's happening? For example, here the water, this is the layers of the water. So the upper layer or the higher the layer near to the surface will gain energy from the surrounding, and then they could overcome the intermolecular force or the bonds between the molecules. So, and then they could escape to the surrounding. Let's put this into words. What will happen? The upper layer near the surface will gain high energy and overcome the intermolecular force between them, between the molecules, and escape to the surrounding. That's all for this question. With the 2 marks, we scored more than the 2 marks. Thank you. So here another question. The table below describes the conditions of the molecule of a substance in each of the 3 states of matter. In the right column, state which one is this substance. So for example, the molecule has a great distance apart. This is a gas. The second one, the molecules are only able to vibrate rapidly about their fixed position, so there's a solid. And last, the molecules are amongst each other. The attractive force between them, the substance does not necessarily fill its container. This is a liquid type. Then we will move on to the next question. We state of matter just before the substance boil. Let's have a quick look about our graph. Before it melts, this is the melting state. Before it melts, it was a solid. So here he is asking about before it boils. So before boiling, it's a liquid. Okay, and then describe what happens to the molecule during boiling. During boiling, what's happening to the molecules? The molecules are molecules. What's happening to the molecules? The molecules are the temperature or the temperature supplied to the system. So during boiling, what's happening here? Actually, all the particles here are gaining heat, so that they could overcome the intermolecular force or the bonds between them, and then they could change the state could be changed from liquid to a gas. So here we could say that the particles will gain heat, and in order to overcome the intermolecular force and change its state to a gas. And that's for this part. Okay, let's move on to state the difference between boiling and evaporation. Okay, state the difference between boiling and evaporation. This was boiling and evaporation. What's the difference between evaporation and boiling? First, evaporation happens in only the surface or only the first layer, while the boiling happen in the whole liquid. Evaporation could occur at any temperature, while the boiling happen at a specific temperature. Evaporation had no effervescence or no bubbles, while boiling had bubble. So you only choose two and then you write them here. What's the state of matter just before a substance melts? So before a substance melts, let's go back to our curve. Before the substance melts, what will happen? The substance will be in a solid state. Okay. At last, aluminum melts at 660. At what temperature does it freeze? We said before that in order to change from a gas to a liquid, this is called condensation, and then from liquid to a gas, this is called a solidification, okay, or freezing. So now, in order to change the state from liquid to solid, what will be the temperature here? The starting temperature. He said that the melting aluminum melts at 660, which means that instead of having a zero here, all the numbers will not be like this. So here the melting start at 660 degrees Celsius in order to move from solid and then melting to go to liquid. But what will happen? This liquid will be a liquid, and then its temperature will decrease till what temperature? So that we could see that the liquid will be freezing or solidified into a solid. So it will be at the same temperature of the melting. Then هما اتنين, يعني if you are writing the melting up, you are writing freezing down. They are taking place at the same temperature. So what's this temperature? It's the same 660. So we could write here 660 degrees Celsius. It will be perfectly right. Okay, here another question shows the equipment used to demonstrate the thermal expansion. Here, as you can see, there is a new question, copper rod fixed from here, fixed inside this block. So whenever there is a heat underneath of this, what will happen to this copper rod? This copper rod should expand, so it will not be able to expand in here. Why? There is no space in here. It's fully fixed in here. So what will happen? It will start to expand that way. So it will, as if it will move this way towards the left. So then what will happen to this roll? When you move this roll that way, in this direction, what will happen? This roll will move anti-clockwise also in the same direction. So this pointer will be, instead of here, will become here. So here, draw the new position of the pointer. You can draw the position like this of the pointer. That's the new position of it. Okay. This is for number A. As the rod is heated, some of its property changes. Identify how each property changes. Place one tick in each of the table below. Property, the volume. Yes, for sure, the volume will increase. Why? Because volume is length times width times height. And we will have an increase in the three of them, length and width and height. So yes, it will increase. What about the mass? Oh, the mass will not change. It's the same material. We did not take any part of this material and we did not add anything to this material, so it will stay the same. What about the density? Let's see. Density is equal to mass over volume. When the volume increase, they are inversely proportional to each other, the density will decrease. So the density will decrease. So just one disadvantage of thermal expansion. We could say that one of the things that is not good about thermal expansion, the idea, for example, of the telephone post or the electrical cable. This is the electrical cable. During the summer, what will happen? The electric cable will expand, and so it will increase in the length, and so it will be just near to the ground, and this is one of the disadvantages. During the winter, what will happen? The telephone posts will be something like this. will be contracted. And that's why one of the disadvantages of the thermal expansion, that the telephone cable or the electric cable will be near the ground. Near the ground. You should specify the telephone cable or the electrical cable will be near to the ground. Thank you so much. Here we have another question regarding the pressure of a gas sealed in a container varies during a period of time. Which of the following statement could explain its variation of pressure? As you can see, the pressure is decreasing. It's moving from this point down, so it's decreasing. So when the pressure is decreasing, what should happen? Actually, when the pressure is decreasing, the volume should increase, and the temperature as well should be decreasing. Okay, that's for this part. Let's move on to show some of a gas trapped in a cylinder with a movable piston. This is this piston is movable. The temperature of the gas is raised. Okay, so what must happen to the piston, if anything, in order to keep the pressure of the gas constant? For sure, heat here, so the gas molecules would start to move faster, make move towards the wall of the container, and so they will apply a force in here. Once they apply a force in here, this piston will move to the right. So if you said it will move to the right, it will be okay. Move to the right. State your reason in your B I. Whenever the temperature increase, what will happen? When we talked before about that the temperature is increasing, and so the pressure will increase, and so the piston should move towards the right in order to decrease the pressure. So the piston will move to the right to decrease the pressure. Okay, that's why the piston moves to the right, because the temperature increased and so the pressure increased. The piston will move to the right in order to decrease this pressure, and so it keep the pressure constant.